So yeah, my talk today is called Securing Angular Applications, and we're going to look at it through the lens of using the client library and then the new HTTP interceptors that were reintroduced to Angular with version 4.3. Just a little bit about me. My name is Ado Kukic. I work as a developer evangelist at Auth0, where we live and breathe JSON Web Token authentication, security, and making it super, super easy for you to implement modern identity in your Angular applications without having to build it yourself. If I don't get to answer all of your questions, you can follow me at Kukic Ado, and I would be happy to follow up with you with anything, any questions or feedback that you have on this talk. So let's talk about SPA security and Angular in particular. The bad news is there's really no way to secure a single-page application, and that includes Angular. The reason for that is they live entirely in the browser. So these applications, you can't have secret keys in them. Anything you put out there, no matter how, you can minify it, you can try to jumble up the code, but somebody determined enough can look at that source code and reverse engineer it, so why even try? So when it comes to single-page application security, we have to take a much different approach than the approach that we traditionally take. So traditionally, when we look at building applications and we're building, say you're building an application for your company and you're building a monolithic application that has its client, front-end client and back-end server living on the same domain. Well, in that case, it's pretty trivial to add security and to add authentication with cookies. And the way that works is your user comes to the site, they sign up, they put in their credentials, you verify those on the back end, and if it's all good, you set a session cookie for your user with the session ID in their cookie storage, and you can identify that user. When they click on a protected resource, you look at that cookie, you do a database lookup, see if that session is still valid, look up the user. If they have the permissions to access that page, you serve the resource, and it's all good. This is a tried and true, tested way of implementing authentication in your system, but this doesn't translate well to Angular applications. And the reason for that is your Angular application will typically live on a separate server, on a separate domain than your API. So the quote-unquote modern way we build applications is we have an API that basically is like a RESTful service or a GraphQL service or however it fulfills resources. It lives in its own domain, and let's just say it's at api.yourapp. Now, when you deploy your Angular application, it might live on a different domain. It could be app.yourapp, for example. Or it doesn't even have to live on this domain. If you can have it live anywhere you want, and even if it's not an Angular application, you might build an Ionic app, you might build a native mobile application. So now you have various clients that are completely decoupled from your backend API, from your backend services. And in this case, cookie authentication and cookie-based authentication will just not work. And the solution to that is token-based authentication, and specifically JSON Web Token-based authentication. So to quickly explain how that works, your user will come to your client, whether it's an Angular, Ionic, or whatever type of app you have. They're going to put in their credentials, and you're going to validate them, make sure that the user is who they say they are. And then rather than creating a cookie, you're going to generate a JSON Web Token and send it to the client. Now, this client is going to take the cookie, and in Angular's example, they're going to put it in local storage, in cookie storage, and session storage, wherever they can kind of persist it. And then every time you make a request to a protected resource, you're going to send this JSON Web Token with that request. And the way you're going to do this is you're going to add an authorization header to your request in the format of authorization, the keyword bearer, and then the JSON Web Token. And your server is going to validate that the JSON Web Token that was sent with it was actually one that was generated by either your application or a trusted resource like Auth0 or a different third party that you've delegated to basically generate JSON Web Tokens on successful authentication requests. and it's going to validate each and every request that you send. And if it's valid, it's going to serve that resource. If it's not valid, it's going to come back and say, we can't fulfill this, give you like a 401 unauthorized and tell you can't do that. Now, for those of you guys who aren't familiar with what JSON Web Tokens are, I'll do a quick 90-second introduction and deep dive. So basically, to my right, I guess, is a representation of what a JSON Web Token looks like. And it's basically a string of random characters that are that kind of don't mean anything to us as the end user, much like a session ID. It's just a random set of characters. But these sets of characters, they have meaning. And each JSON Web Token is comprised of 3 parts. The header, which you can see in red, and the header basically tells you what type of token this is. And in 99.9% of the cases, it's going to be a JSON Web Token. And then the other attribute you're going to have in this header is going to be the algorithm used to sign the JSON Web Token. So in my example here, I'm using the HS256 algorithm. Now, the payload seen in purple is really the meat of the JSON Web Token and what you're really going to care about. This is the claims, the properties, the data that you're going to want to put in your JSON Web Token to identify your user, to add context to what this authentication basically to what this token is. And there's different types of claims or properties you can include here. There's reserved claims, which are reserved by the organization that kind of wrote the standards for JSON Web Tokens. And examples of those are like the ISS token, which stands for issuer, which is the organization, the entity that you trusted to generate the token. Another one is the SUB claim, the subject claim, which is basically like the user ID. And then there's public claims, and these claims are important because these are claims that help you with interoperability. So if you're using JSON Web Tokens, it's likely that you're building a RESTful or GraphQL API, and you want to make this API work well with other applications. So if you're implementing kind of standardized protocols for how you represent your users, how you represent addresses and other common attributes, it makes it much easier to work with your API. And then finally, there's private claims, and these claims are kind of specific to your application domain. Like for my example here, I have a role property, and mine is speaker, but I could represent this any way I wanted. I just did a string here, but I could do like an integer where 1 is an organizer, 2 is a speaker, and 3 is an audience member. But basically with these claims, they're specific to your application and your application domain, and you can just kind of go wild and do whatever you want. So you could put any valid JSON data as your payload for the JSON Web Token. And then finally, the third part of a JSON Web Token is the signature. And there's different signing algorithms you can use to kind of sign this token and ensure that it's secret. And that with JSON Web Tokens, they're not encrypted, so anybody can take a look at this JSON Web Token, put it in a JSON Web Token decryptor, and see the contents inside it. But with a signature, you have to know the secret to verify it. So if you're using the HS256 algorithm, the secret is just a string of characters that you choose. So it's basically like a password. So this HS256 is really easy to demo and really easy to work with, but it's not as secure as RS256, for example, where it's a public-private key pair. So the private key signs the token, and then if you have a public key, you can verify that the private key signed this token and that it's a valid token. So that's basically how JSON Web Tokens work technically. To explain it in another term, it's basically like in a non-technical term. Basically, the stuff on your left-hand side is like a letter that you would get in the mail that your friend would write you. And when you open that letter, you can read the contents, and anybody can open that letter if a mailman thinks, oh, I want to open this letter and see what's inside it. They can read it, they can read the contents within it, but if you know your friend's signature, you can verify that, hey, my friend actually sent me this letter and not my enemy or somebody spamming me. So that's one way to think of JSON Web Tokens. They're not a security mechanism, they're just a way of easily transporting data. And this brings us into how we work Angular applications with JSON Web Tokens. So how do we integrate JSON Web Tokens into our Angular applications? And there's really two ways. One is using the built-in provided HTTP client library, which works really, really well. And the other way is using HTTP interceptors. And if you've worked with Angular 1.x before, you'll be familiar with interceptors. If not, I'll explain what they are in just a little bit. And then there's non-Angular ways to kind of work with JSON Web Tokens in your Angular applications. You can use a trusty old XML HTTP request, or the new Fetch API also allows you to work with headers and add JSON Web Tokens. But we're not going to talk about the other ones because the HTTP client library is actually built on top of XML HTTP request. It's just syntactic sugar that makes it really easy to work with making HTTP requests. And if you guys have done any work with Angular, made any API call, this code should look really, really familiar. You're just doing a simple HTTP to invoke the library, and then the method, get, post, put. And since this is an observable, you're going to subscribe to it, get the data, and then do whatever you need to the data. Bind it to a property, console log it, what have you. Adding a JSON Web Token to this client library is also fairly trivial. So again, you're going to use the HTTP headers library from the HTTP client library, and basically you just invoke you create a new HTTP headers object, add which headers you want to add, and in my instance, again, I'm adding a bearer, adding the JSON Web Token, and then I'm going to append it to my request. And the way I'm going to do that is simply add a second property to my GET request. So I'm going to have my API URL and then the headers that I want to pass along with that request. So without adding that second property, even if I have the headers enabled at the top, they're just going to sit there and not do anything. And this works really well for smaller applications. If you're working with just a handful of API calls, this is really, really simple and works well enough. But the issue you're eventually going to run into is error handling all of these HTTP requests. So you might want to check to see if the user is authenticated. And if you have 50 different API requests, writing this code is going to get really, really repetitive. And you can write like a helper library to kind of take care of errors for you. But that's, again, adding complexity to your applications. And there's a much better way to do it, I think. And that is with interceptors. And I think this is a good example of how they work without actually explaining them. But I'll explain them anyway. So Angular interceptors, as the name implies, intercept HTTP requests and allow you to modify the request and response to fit your needs and do this globally. So rather than adding that authorization header to every single request, you can just create an Angular interceptor, and every single time you make a HTTP request, that header is going to be added, the JSON Web Token is going to be added, and you can kind of fire and forget about the interceptor. And let's take a look at what the Angular interceptors look like. So they're basically an injectable, so they're a service. And to create an interceptor, you just have to satisfy the HTTP interceptor interface, which is really just one method called intercept that takes two parameters, an HTTP request, and that could be any. It could be get, post, put, whatever other verb you had, and then a HTTP handler to kind of push that request down the chain to complete the request. And since the HTTP request is immutable, to make changes to it, so to add the authorization header, we're actually going to have to use this clone method. And when we invoke that, we get a whole set of different parameters, options that we can add to our headers. We can remove stuff, add stuff, and then add it back to the request property or reassign it back, and then just pass it in this next handle, which is just going to send it down the chain. And the reason we do this next.handle is because we can have multiple interceptors. So you can have one or many interceptors, and each of them doing a different thing for your application. Or you can kind of like look at the request that's coming in and see if it even needs to needs this interceptor. So say you're building like an API that is public to read but private to create resources. So you might look at this request object, look at its method, and if it's a get, not even add the authorization header because it's unneeded. It's just adding data to your requests. But if it's a put, post, get, or delete, then you might want to add the authorization header. So that's kind of how interceptors work in theory, and let's quickly look at a demo of how they work in the real world. So I built this kind of simple application that is going to allow us to log in and get a JSON Web Token, and then once we're authenticated, we're going to be able to call an API that's protected that needs a JSON Web Token to work. And my API is a very simple Node application running on Webtask, and it has a JSON Web Token check middleware that's going to check the incoming JSON Web Token, validate it, make sure that it actually came from Auth0, the provider that I set up, and then once it's created or once it's verified, it's actually going to go and fulfill the request. And the request is going out to Giphy and returning a random GIF with the tag New York. Now, I set the rating here to PG-13 because you get some really weird GIFs from Giphy, and for my testing, the GIFs that I usually get are like either like sports teams or the Real Housewives of New York. So we'll see what we get. And just to show you that this API is protected, I'm actually going to do a GET request without passing any tokens to it. And I'm going to get an error saying no authorization token was found. So we made a request to the API. It looked for an authorization header with a JSON Web Token. It didn't find it, so it just short-circuited the application and said, you can't go, you shall not pass. So let's go into our application now, log in, and I'm just going to log in with Auth0. I mean, you don't have to use Auth0 for this. You can use your own authentication system, but just to make it a little bit quicker and easier, I just implemented Auth0 in the application. So I'll log in with GitHub because we're all developers here, and I'm going to call the NYC API, and let's see if we get an image back. We do. So it works. So the reason that works is here in my HTTP request to the Webtask backend, I am passing in the headers that I created up here. If I were to remove this property, I'll just remove it. So I'll open up DevTools. And now if I call the NYC API, I'm going to get an error that says, hey, you're unauthorized. We didn't find an authorization token. So it's basically that same error that I got when I accessed it via the browser, saying that we can't find an authorization token. We're not going to get you. We're not going to send you a GIF. And then just to show you guys another kind of interesting thing with SPA security, with Angular security in particular. So I'm logged in now. And I can tell I'm logged in because I have a logout button and I have this call NYC API button. And I only display that if my user is authenticated. And the way that I'm saying that, I'm counting the user authenticated if they have this expires at property, if they have an access token and an expires at property in local storage. But if I were to, say, remove the access token, remove the ID token, and I'll just copy this guy for now. I'll remove all three, refresh the page, and now I'm not logged in anymore. So I can't call that API because I can't see it in the UI. But if I go into the code, kind of hack around it a little bit, and figure out that the expires at property is the property that cares about, that kind of controls the UI and tells me if I'm logged in or not. If I just add the expires at property, refresh the page, now I'm technically logged in, even though I don't have a valid access token. And this is why you can't really secure a client-based application. The good thing is, though, since I don't have a valid access token, I won't be able to call this NYC API. So no matter how many times I click it, I'm going to get an error saying, you're unauthorized. You can't, you basically can't do that. Because you don't have a valid access token. So I'm going to log out again here and log back in. And then just to make things a little bit simpler, let me show you the implementation. So here we had the example where we were using the headers in our application. But now if we go and create an interceptor, and I already created one for you guys, so you don't have to watch me try to code for 10 minutes. But basically, I'm just creating an interceptor, calling it auth interceptor, and cloning the request that comes in, adding an authorization token, again with that format of bearer, and then the JSON Web Token. And then another thing that I didn't show you in the slides is this next HTTP handler. We can actually do something else on it. We could do global error handling right here. So rather than trying to manage the user state, trying to look and see if when a user try to log in or when they try to access a resource, if they get it unauthorized and trying to handle it within our services, we can actually do that globally here. And if they're not logged in, we'll just redirect them to the login page. So I've implemented that here. I'll go back into my app module now to actually start using this interceptor. And to use interceptors, you basically just define them in your global ng module. And you can have multiple interceptors, as I said before. So here I have this multi-property set to true. So if I were to set this to true, now I can add as many other interceptors as I want, and they're going to execute starting from the top to the bottom. And then if I only had this one interceptor, I technically don't need this property, or I can even set it to false. It's just depends on your coding style. So now in our application, we're not passing a header in the original HTTP GET request, but we do have this interceptor working for us that's going to basically do that for us. So if we go back into our application, provider parse errors. Let's see. Maybe things changed. Yep, I guess you do. So now I'm going to make a call to the NYC API, and again, I get a GIF because I'm using the interceptor to attach the token to the request, and I can verify that by going to the network tab, and let's see, right up here in the request, we can look and see that the authorization token is attached with our JSON Web Token that was generated by Auth0 and sent to us when we logged in. And one final thing, so if we were to remove this access token and try to call the NYC API again, since we added that global error handler in the HTTP interceptor, rather than giving us an error now saying that you can't, rather than like console logging an error, it's actually going to take us to the login page because it's going to see that we're not logged in, we don't have an access token, and our HTTP interceptor we coded to redirect the user to the login page if it fails. So I'm going to hit call NYC API, and I'm redirected to the login page to log in before I can request that resource. So again, I'll log in, get my access token again, and call the NYC API. And luckily, we didn't get any bad GIFs, I don't think. So that really concludes my presentation. And I don't know if we have a couple minutes for questions.
Is it on? OK, cool. So I guess my first analogy question was you called it like a letter. Wouldn't you say it's more like a postcard since you can read it and then it's right?
That's a better one.
Okay.
Yeah.
and then the follow-up was so you're using WebTask as your API gateway to the Giphy, and that's sharing the secret that's sharing the secret that's being distributed by Auth0, correct?
Yeah.
So when you set up Auth0, you just get the secret and you stick it in there.
Yep. So when you sign up for Auth0, you basically configure your backend API. You get basically you could copy and paste a snippet of code that's going to verify the token, put it in your application, whether it's a Node application, a Java application, whatever your framework is. Thank you, guys.